Professor Pelton. This is Algebra 2, Chapter 5, Section 4. This is Part 2. And these ones, we're going to have what's called extraneous solutions, where when you do the solving process, you will get solutions that are not valid. Okay. So, as a result, you need to plug in your solutions so that you can prove that they are valid. If not, they're not valid. So you can get multiple solutions here. So what you're going to have happen is you're going to get multiple solutions in a lot of these, because you cannot necessarily use isolation here because we have multiple powers of x. This is x to the first and x to the 1/2. So the typical isolation strategy will not work. So in this case, the goal here is to get rid of the radicals. To do so, we're going to use exponents to do so. So since this is a square root, we're going to use a square on both sides to cancel the radical. Since it's a square root will cancel it. So we can think of this as x plus 1 times x plus 1 on the left-hand side, because squared means multiplied by itself, right? And on over here, what you really have is 7x plus 15 to the 1/2, because that's what square root is, all to the second power. So this gives us x squared plus 1x plus 1x plus 1 on the left, which is 7x plus 15. And power to power rule says multiply, so that's 2 over 2, which is 1. So that gives me x squared plus 2x plus 1 equals 7x plus 15. So now this is a factoring problem, which is what we should have expected. Isolation method should not work. Factoring will, because you have multiple powers of x. That's an indication it's going to be a factoring problem. So we'll move all of these terms to the other side. So we have 1x squared minus 5x minus 14 equals 0. So if we factor, we get 1x and 1x. 1 times negative 14 is negative 14. So that's 1 times 14, 2 times 7. But the thing is, one of these has to be negative. So either the first one is negative, or the second one is negative. This must add up to negative 5. So 2 and negative 7 will work. So positive 2 and negative 7 will give us our negative 5x when we multiply it back. So x plus 2 is equal to 0, and x minus 7 equals 0. So minus 2, x is negative 2, and add 7, x is 7. But again, extraneous solutions, one of these might not work. So if you plug in negative 2, okay, plug in negative 2 there, you'll get negative 1. If you plug in negative 2 here, you'll get negative 14 plus 15 is 1, square root of 1 is 1. Negative 1 does not equal 1 when you plug in negative 2. However, if you plug in 7, different story. If you plug in 7 on this side, you will get 8. If you plug in 7 on this side, okay, you'll get 49 plus 15, which is 64. Square root of 64 is 8. Therefore, this is the solution 7. This one you should put the line through, because that is extraneous. You can abbreviate there. Okay? So 7 is the answer. Let's try the right-hand side. So again, we want to cancel the radical. So we're going to need to square both sides. So square root of x plus 2 plus 1 squared equals 3 minus x square rooted squared. Okay, so on the left-hand side you have two terms. So that's going to be root x plus 2 plus 1 times root x plus 2 plus 1. And on the left side, since it's a square and a square root, you're just going to be left with 3 minus x. Okay, so if we distribute, we get root x plus 2 squared, because it's times itself, plus 1 times root x plus 2, plus 1 root x plus 2, plus 1 equals 3 minus x. So we'll combine like terms. Well, we'll simplify first, because over here these will cancel, leaving with x plus 2, plus 2 root x plus 2, plus 1 equals 3 minus x. So we'll combine like terms again. So we have x plus 3, because we have the 2 and the 3 there to combine, plus 2 root x plus 2 equals 3 minus x. So we'll combine further. Well, minus x and minus 3. So it gives me 2 root x plus 2 equals, well, that's going to be 0, so that's going to be minus 2x. Okay, so now we've got rid of one of the radicals, but not both. So as you can see in problem A, there's only one radical. So squaring at once got rid of one radical. So in B, there are two radicals, which means you got to square twice. But before we do that, let's divide by the 2. So we get root x plus 2 equals negative x, or negative 1x. So now we can square for a second time. So if I square for a second time, I'm going to be left with x plus 2, because again we have a square and a square root, equals, well, x squared is x squared, but there's a negative there. But if you square a negative, you get a positive. Okay, so we're almost there. So I have x plus 2 equals x squared. This is a factoring problem since we have multiple powers of x. So we'll move the terms to one side. So I get 0 equals x squared minus x minus 2. Okay, so let's get our factors. 1x and 1x. So 1 times negative 2 is negative 2. So the factors here are 1 times 2 or 1 times 2, or one of them has to be negative. But the only option is positive 1 and negative 2, because that gives us negative 1 when we add them, when we multiply it back. So x plus 1 equals 0, and x minus 2 equals 0. So x is negative 1, and x is 2. So like before, you can't just assume both of those are answers. You need to plug them back in to verify. So if I plug in negative 1 back to the original problem, I'm going to get 1, square root of 1 is 1, plus 1 is 2. If I plug in 1 here, I'm sorry, negative 1 there, I get 4. Square root of 4 is 2. So this one actually works, so that's an answer. However, let's try 2. If I plug in 2, let's see what I get. So if I plug in 2, I get 4. Square root of 4 is 2, plus 1 is 5. No, I'm sorry, 3. I said that wrong. Square root of 4 is 2. Okay, so if I plug in 2 here, I get 3 minus 2 is 1, square root of 1 is 1. That's clearly not equal, so that one is extraneous there. Okay? Alright, pause the video, try the next two problems for yourself. Okay, next two problems, they both have multiple powers of x. They have x to the 1/2 and x to the first power. Thus, isolation is not going to work here. The goal is to cancel the radicals by doing squares to both sides, or exponents. So 10x plus 9 squared and x plus 3 squared. Okay, so that'll cancel on the left side. So we're left with 10x plus 9. And on the right side, we're left with x plus 3 times x plus 3, because exponents may multiply by yourself. It's squared, so it's multiplied by itself once. So 10x plus 9 equals x squared plus 3x plus 3x plus 9. So 10x plus 9 equals x squared plus 6x plus 9. So we'll move all to one side. So 0 equals 1x squared minus 4x plus 0. So again, we knew this had to be a factoring problem because of the fact we had multiple powers of x, therefore isolation would not have worked. So we'll do our factoring. So we have 1x, 1x, and this is 1 times 0 is 0, but there are infinite multiples that give you 0. So here, the only thing that would make sense is 0 times negative 4, because that'll add up to negative 4. So it's plus 0. And minus 4. So multiply that back, we get the original problem. So x plus 0 is 0, and x minus 4 is 0. So x is 0. And if we add 4, x is 4. We shouldn't assume that 0 worked, though. Let's actually check that. So if we plug in 0, we get 9. Square root of 9 is 3. If we plug in 0 here, we get 3. So that actually works. That is an answer. That was correct. If we try 4, though, does 4 actually work? I don't know. Let's try. So if I try 4, 4 plus 3 is 7. Okay. So we try 4 here. I get 40 plus 9 is 49. Square root of 49 is 7. So in this case, they both actually work. Okay. So you can't assume they both work or one of them doesn't work. You have to check each time. You're going to get a variety of outcomes. Okay, next problem. So this problem has 2 radicals, which indicates I'm going to have to use 2 exponents to get rid of the radicals, which is the goal. So since it's a square root, we'll square. So root x plus 6 minus 2 squared equals root x minus 2 squared. So on the left-hand side, we have 2 terms, so I have to multiply it by itself. X plus 6 minus 2 times root x plus 6 minus 2. And on the left side, we're just left with x minus 2, because all we have is an exponent and a radical, so they will cancel. Okay, so if we distribute now, we will get root x plus 6 squared, because it's times itself. Minus 2 root x plus 6, minus 2 root x plus 6, and plus 4. Okay, so we'll simplify further. So we have a cancellation here for x plus 6, minus 4 root x plus 6, plus 4 equals x minus 2. We can combine further, so we get x plus 10 minus 4 root x plus 6. So we can combine the 6 and the 4 there on the left-hand side. Okay, we'll move everything to the right-hand side to combine further. So we'll minus x and minus 10. So negative 4 root x plus 6 equals negative 12. So I get rid of one radical, now we get rid of the other by squaring again. However, I want to simplify a little bit first by dividing by negative 4. So that'll give me root x plus 6 equals 3. Now we can do the final squaring to get rid of the last radical. Okay, so we'll square both sides. So we'll be left with x plus 6 equals 3 squared is 9. Okay, because again, it's a square root, so cancel, cancel. So minus 6, and x is 3. Let's not assume it's an answer, though. So if we plug that in, let's see what we get. 3 plus 6 is 9, square root of 9 is 3, minus 2 is 1. Plug in 3 here. 3 minus 2 is 1, square root of 1 is 1, so that actually works. So x equals 3 is a solution, and that is the end of part 2.